Welcome back. So, previously, under the topic of channelization, we had discussed two techniques, namely FDMA, which is frequency division multiple axis, and TDMA, which is time division multiple axis. Now, the third technique, which I would like to discuss, is the technique which is named as CDMA, which is code division multiple axis. What exactly is CDMA? So, how in FDMA every user was given a distinct frequency, or in TDMA every user was given a distinct time slot. In CDMA, every user is given a unique, distinct specific code. Okay. So it's like saying that multiple users, when they are transmitting their data, each user is going to use the specific code that has been assigned to their device on their data and then transmit out the data. So as mentioned in the slide, one channel is going to carry all the transmissions simultaneously. Okay, which means every station is going to code its data with a specific code that is unique to that user before transmission. And once this data, transmitted data, is received by a particular receiver, the receiver will then use the code that was used by the specific sender in order to recover the desired data. So let's take an example how exactly it works. We'll start off on a simple note. So let us suppose that there are 4 devices, 1, 2, 3, 4, and each of them are having their own data, D1, D2, D3, D4 respectively. Now in CDMA, every user is assigned a unique code. So in this case, let us say station 1 is assigned the unique code C1. Station 2 is assigned the unique code C2. Station 3 is going to be assigned the unique code C3, and station 4 is assigned the unique code C4. So basically what's going to happen, all the transmissions will be happening parallelly, let's assume, in the common channel, wherein what exactly is the data that is going to be traveling through the common channel? It is going to be the sum of the respective product of the station's data code with their unique code. So D1 is going to transmit out D1C1, D2 is going to transmit out D2C2, D3 is going to transmit out D3C3, D4 is going to be transmitting out D4C4, and what is actually traveling in the media is the summation of the respective products. Let's go a little more specific in detail to an example. So now how it works, bit 0, number 1, what you need to remember, bit 0 will be represented by -1 and bit 1 will be represented by +1, and wherever there is silence, that's equivalent to a 0. So let us stick to our same example of 4 stations. Let us say that station 1 is having a bit 0 to transmit, station 2 is having a bit 0 to transmit, station 3 is silent, and station 4 is having a bit 1 to transmit. So all zeros will be represented as -1, silence will be represented by 0, 1 bit will be represented by +1. Now the unique code which is assigned to every station is shown in red color. For example, for station 1, the unique code will be +1, +1, +1, +1. And for for station 4, the unique code will be +1, -1, -1, +1. So what exactly is happening? Every station's bit, okay, the representation of that bit is going to be multiplied with the unique code. So let's take one example. So for example, if station 2 is having bit 0 to transmit, that is going to be represented by -1. Why? Because all zeros are represented by -1. So now this -1 is going to be multiplied with the unique code which is assigned to station 2. So minus 1 multiplied by plus 1 minus 1 plus 1 minus 1 will result in minus 1 plus 1 minus 1 plus 1. So now every station is going to calculate the product of D1 into C1, D into C. And eventually what is going to travel through the common channel is, now in this case, why is it minus 1, minus 3 plus 1? So every station's respective bits are going to be added cumulatively, and that is going to be transmitted in the media. So it's like saying station 1's first bit is minus 1, station 2's first bit is minus 1, station 3's first bit is 0, and station 4's first bit is plus 1. So when I add them up, minus 1, 0, plus 1 will give me the answer as minus 1. Another example, why is the third bit minus 3? Because the third bit of every station is going to be added cumulatively, and what is getting transmitted is the summation of those respective positions values. So in case of station 1, it's minus 1. In case of station 2, it's minus 1. In case of station 3, it is 0. And in case of station 4, it's minus 1. Right now, we are talking about third position. So this is how CDMA works. To go a little bit more in detail, now this is only the aspect of the transmission. How will the intended receiver extract the actual bits from the data that has been transmitted? So let's go a little bit more in detail. So if you look in this example, there are two users. Okay, if you look at the power of D, one power is 1 and the second power is 2. So it is like saying that there are two users, 1 and 2. Okay. Now, let us assume, or let us, as you can see in the example, user 1's data is minus 1, 1. Matlab, the 0th bit is 1 and the first bit is minus 1, which means when I'm representing something by 1, it's actually bit value of 1. And when I'm representing something as minus 1, it is actually representing bit 0. So right now, station 1 is having the data 0, 1. And station 2, which is below, is having the data 1, 1. What is the unique code for user 1? 1, 1, 1, minus 1, 1, minus 1, minus 1, minus 1. So as you can see, the unique code for user 1 differs from the unique code of user 2. User 2's unique code is 1 minus 1, 1, 1, 1, minus 1, 1, 1. So number 1, whatever is the data, you have to represent it in the respective format. Matlab, all zeros will be represented by minus 1. All ones will be represented by plus 1. And if there is silence, like if there's no data to send, that's equivalent to 0. So now what is going to happen? For example, where it is written D to the base 0 power 1, matlab this is user 1 ka bit, what you can say, the first bit on the right. So if it is 1, ye jo 1 hai, that is going to be multiplied with the unique code. And finally, what are you going to get? See the value given in blue. It's just multiplication bit by bit. 1, 1, 1, minus 1, 1, minus 1, minus 1, minus 1. So every bit of the user is going to be multiplied with the unique code to get one value. And then what are we doing? We are going to take summation of the respective users' values. Okay. So now what is happening? You have got D1, C1 for user 1. You've got D1, C1 for user 2. You are going to add them up. So how is the addition happening? So if you look at the blue section for both the users, you simply have to add them up. So on the top, it is minus 1. Below it is 1. So you add them up. Minus 1, minus 1. Here it is 0. Follow the arrow very, very carefully. Then the next value is minus 1 on top and 1 below. So when I add them up, it is again a 0. Take the third value. On top, it is minus 1. Below, it is minus 1. So the summation is minus 2. So this is your bit-to-bit products addition. So finally, what you are transmitting is this particular data, which I'm representing as Z with a star. Now, this data is going to be commonly received by the different users. and it is a role of the receiver to extract the actual data from the received data. So let us assume that this data has now been received by the receiver. So if the receiver is interested in user 1's data, he has to use the unique code of user 1, which is 111 minus 1 1 minus 1 minus 1 minus 1. And if he is interested in user 2's data, he has to use the unique code 1 minus 1 111 minus 1 1 1. So now let us assume that you want to extract the data of user 1, which was what? Minus 1 and 1, which you can see on the top. So how will I extract? Whatever data I receive. Now see the formula. It is summation of Z star into C upon capital M. What is capital M? Capital M will be the total length of the received bits. C is going to be the unique code that you are applying of a particular user whose data you are interested in. And Z star is nothing but whatever data you have received. For example, now if I'm interested in extracting user 1's data, whatever data I have received, I am going to apply the unique code of user 1. Okay, what is the unique code? I already mentioned. Now what I'm going to do, I am simply going to multiply Z star with the unique code. Okay, and then I'm going to take the product of the sum of the product. So how does this work? So now if you go at the last bit, this is 0 on top, 0 into minus 1 plus 0 into minus 1 plus minus 2 into minus 1 plus 2 into 1 plus 0 into minus 1 plus 2 into 1 plus 0 into 1 plus 2 into 1, the whole divided by m, which is right now 8, is going to give me the value as 1. Okay, this is how you are going to extract the original bit that was transmitted. And likewise, how do you get minus 1? Look at the leftmost 8 bits. So it's going to be going from going from the least significant bit to the most significant bit. So it's going to be 2 into minus 1 plus 2 into minus 1 plus 0 into minus 1 plus 0 into 1 plus 2 into minus 1 plus 0 into 1 plus minus 2 into 1 plus 0 into 1. The whole upon 8 is going to give me the value minus 1. So this is how CDMA works.